Welcome back everyone and welcome to today's class. Today we are going to discuss another firewall feature, and that is policy-based routing. Usual routing is always based on the destination IP address, but you can base routing decisions on other types of variables. You can base it on source addresses, so perhaps everything from this inside network with this IP address will go one way and everything else another way. You can base it on layer 4 information, so perhaps a specific protocol like HTTP will go a different direction. And you can also base it on QoS markers and a whole lot of different things. Okay, so how do we define this? A common use case for policy-based routing is a design like this. This is the same design as the last lesson when we talked about traffic zones, and the same configuration as we had at the end of that lesson. So we have a common traffic zone named outside, which both these zones are linked to. And then we can send our primary traffic through ISP1 and use ISP2 as a backup link. And even if the packet takes this way and comes back this way, it will still work and it'll forward it to the correct computer. And we have defined not based on the any keyword, and we have made access lists global. Okay, so how do we do policy-based routing in this case? Let's say we wanted to do exactly what I said before. We want to send all traffic through ISP1 with a few exceptions. We want to send HTTP and HTTPS traffic out this link, and we do also want to send all the traffic originating from this network or this IP address range toward this send. Okay, so let's do this. First we need to identify this traffic, which means we need to have access lists and classes for those different types. So let's create, let's see, I think I have a network object for this one. Let's check the objects first. So we have one called 193 network, but that is just the range. And then we have the DMC network. So we'll use the DMC network for the source routing. And for the layer 4 routing, we will create an access list for that. So let's see. We'll do access list HTTP, and we'll permit TCP any equal 80 and 443. Like this, and we will create an access list for this network's source routing as well, and we'll just call that DMZ. So we will permit all IP traffic from object DMZ to anywhere, and that's it. So now we have defined the access list. Let's create two classes as well. That's basically to tie it together. So class map CHTTP match access list HTTP. And class map CDMC match access list DMZ. So now we have these two. CHTTP, which matches the access list for HTTP and HTTPS traffic, and we have the DMC one as well, matching the source IP addresses. And now we will create our policy map, and that works the same way as on Cisco routers basically. If you have done policy maps when configuring BGP maybe. So we'll do policy map, and then we will give it a name. Let's call it policy-based routing, PBR. Then we do permit and a number. Did I miss something? Policy map. No, it should be a route map, sorry. Route map, PBR, permit, and then a number. So this is a sequence number. I usually do begin with 5, and then I do 10, 15, 20, and so forth. That makes it very easy to insert stuff in between if we want to add on to those later on, because they are treated by the firewall beginning at the top at the lowest number, and if it matches, it does these rules, and then it continues down the line. So route map PBR 5, and the first we want to check for is the class HTTP. Okay, that's how you do it in the iOS. We don't need to go through the classes as it seems. So we just go back into the route map and we do match let's see, AS path, community interface, match IP address next top, route source, policy list. IP policy map name. It doesn't seem that this virtual Cisco ASA version has the ability to check for layer 4 information. But that's okay. Let's just do the first example then. Maybe I can do a lesson later on when using a hardware-based ASA version, so we can try that out as well. But okay, we'll just do if the traffic is originating from this IP number range, then we will route it out this way. So match IP address, and we'll type in the access list, and we name that ACL. No, we just named it DMC, I think. Specified ACL DMZ cannot be associated with a route map when inactive keyword is configured. Access list DMZ, extended permit, IP, object DMZ, any. When inactive keyword is used. I haven't used the inactive keyword. Match IP address next. Route source. This is the one. Address is for the destination addresses. We need to check for the source address. Standard access list. I think match IP route source. DNC. No, perhaps the problem is that I made, if we look at it, SH run access list DMZ. This is an extended access list. I think that's the problem, that it can't handle extended ones. And that's basically because earlier on, if we use a hardware-based firewall, this type of feature, like policy-based routing, will be handled not in the general purpose CPU using software. It will be handled by an ASIC hardware circuit inside the firewall. And those can only handle very specific tasks and do them very fast. So that's why this is so... this is why it can't handle the extended ones. What did it say? Is attached to a class map. Okay. No class map. And what did we call it? DMZ. Okay. So access list DMZ standard permit. And the network is 193.234.88.0 255.255.255.248. Okay, so let's go back into our route map. Route map PBR permit 5 match IP address DMZ. Oh, this time it works. Okay, so what do we want to do with this packet when we have successfully matched it? We'll use the set parameter, the set command, and we can set all of these different things. But the thing that we are most interested in are the IP next hop. By changing the next hop IP address, we are effectively routing it another direction. So we'll set 212, 16, 16, and 2. And then we will apply the route map. Policy map. So the command for applying it is policy-based routing. Are we doing it with a policy map? It doesn't seem quite right. Isn't it something like route policy or... I need to double check this real fast. Policy route. I thought I did that. Policy route. Okay, we need to go into the interface. Usually you don't do this kind of things inside the interfaces, but okay. It's not always very consistent. Let's see. So the packets will come in from the DMC. So this is the interface, gig03. And we'll do policy route, route map, and we called it PBR, like this. So we should be able to do SH policy route, I think. Do we get more input than this? Doesn't seem like it. Maybe we see more if we do SH route map detail. Route map. PBR detail. No detail, okay. Okay, so route map PBR permits sequence 5. We match for the IP source address based on the DMZ, and we set the next hop to ISP2's IP address. Okay, so how do we verify this? As you remember, both of these routers share a common Anycast address of 5555. So if we try to ping 5555 from the server, we should be able to log that attempt on both of these routers. So let's do something like this. We will create an access list. Access list 1 permit. And this is for the destination, I believe. Access list 1 permit. Host 5555. Log. The log part is the important one, because that bumps it up to the general purpose CPU, and we are able to see it. We will apply that one, do sh brief on the gig 1. No, yes, on the gig 1. And we'll do IP access group 1 inbound, like this. And we will also enable logging. So logging console 7. Logging on. And we will also do debug IP packet, debug ICMP packet, or just debug debug IP ICMP. That's right. Okay, same on this one. So we'll create a standard access list, number 1, where we permit host 5555 with the log keyword. We go into the interface and do IP access group 1 in. And then we do, oh, forgot about the logging. Logging console 7, logging enable. No, logging on. And then we debug IP packet detail and debug IP ICMP. Okay, before we test it from the server, let's test it from PC1. So ping C1 5555. Didn't this work before? Okay. Perhaps we are denying a little bit too much now. Access lists. Section. Okay, so here we go. Let's do permit, access list 1 permit any. So we have an explicit permit all on the end of it. And the same here. But we don't need the log keyword for that one. Okay, so let's try pinging this first. That works. And can this one ping that one? Yes, it can. And it shouldn't produce any logs, no. What if we try the 555 again then? Now it works. Do we get the logs? Let's see. Sometimes it slows down a bit. Nine matches for the permit any. Maybe it's checking the source when we do it like this. Permit 555 log. Let's do an extended one instead. Call this 100. Permit IP, and this is the source, so 193.234.88.0, and here it wants a source wildcard bits, so that should be 000 and 248 in the usual one. That should mean 8, I think, or 7. It was a long time ago I did this. Permit blah blah blah. Any. No, this is not right. It should be any and then host 5555 log. And then permit IP any without the log. go into the gig 1 interface. Remove the old and replace with the new. And we'll do the same here. So we will create an access list number 100, permit IP from anywhere towards 5555 log. Without the IP in this version, and we'll permit IP any without the log. Check the interface. Let's remove the old one and replace with our new one. Are we still able to ping this? Yes. And this? Yes. No logs. But if we ping 5555, let's just send one packet. Okay, we got a response, and here we got a log message from this IP address. So this is in our NOT range. It looks right. Towards 5555. Okay, and we didn't get anything here. Okay, so that's all good and well. If we ping it from this server, then we should get then the packet should be policy routed to the ISP2 instead, and we should be able to see that. So let's start by pinging. Let's see if we can ping the left router linknet address, yes, and the right linknet address, yes. Okay, and there shouldn't be any logs. That's right. Okay, let's see what happens when we ping the 5555. If we go to ISP1, we did get one there. We didn't get any on this one. Why is that? Permitted IP. Let's check our configuration again. Let's begin on the interface level. Policy route, route map, PBR. Are we able to check any policy? No, not like that. Policy routing doesn't seem to be very improved. So route map PBR permit 5. Match IP address from the DMZ access list. Standard permit 193.234 88.0 255.255.255.248, and that should be the source address, right? Yes, it's in that range. Perhaps it's doing the destination when we use that command. Let's go. No. Let's go into this one. And let's remove this and this. And instead we'll do match IP. What about route source? DMC. Set IP next hop 212.16.16.2. So route map PBR permit 5, match IP address route source DMC. Set IP next hop 212.16.16.2. And we have it on the DMC network policy route map PBR. Because it should be on the inbound link, right? Well, let's try it out. So let's enter down a little bit, both of these, and we'll ping the 555 again. This time we didn't get anything here. We do get the response back. And what about this one? Here we go. This time we got an IP packet. And if we were to ping it from this one, we shouldn't trigger that rule. There we go. It works. So today we have learned policy-based routing, how we can influence the routing decisions without just looking at the destination IP addresses. Thanks for watching, and thanks for today.